Welcome to the DIY Honda Garage channel. The DTC P0506 indicates a problem with the idle control system of the 2006 to 2011 Honda Civic. Specifically, that the engine's RPM is lower than expected. This is crucial because the RPM at idle needs to be within a specific range for the engine to function efficiently and maintain stability. The vehicles in this model range rely on various sensors and actuators to control engine speed and air intake when idling. Notably, components such as the throttle body and electronic control module, ECM, are key players in regulating and monitoring engine operations. When an error is detected, it can lead to poor engine performance, rough idling, or even stalling. Thus, prompt identification and rectification of the cause behind this DTC is essential for maintaining optimal vehicle operation. The DTC P0506 refers to an issue with the idle control system, indicating that the engine RPM is lower than expected during idling. This may relate to the malfunction of the throttle body, which is responsible for managing air entering the engine during idle. The throttle body is located between the air intake duct and the intake manifold, making it critical in regulating engine speed. The electronic control module, ECM, processes signals from various sensors to maintain the right idle RPM, and when it detects discrepancies, it triggers the DTC. This diagnostic trouble code can also point toward problems in additional areas, like the engine coolant temperature, ECT, sensor, or the intake air temperature, IAT sensor, which are also vital for the ECM to perform accurately. Finally, understanding the specific role of each component involved is essential for efficient troubleshooting and repair. Several factors could be leading to the P0506 code, with the first being contamination within the throttle body. Dirt and carbon buildup can interfere with the throttle's opening and closing, affecting air intake and idle speed. If the throttle body is damaged, it cannot function as intended, leading to incorrect airflow into the engine. Another potential cause is related to issues with the air conditioning AC system or electric power steering EPS system, both of which can indirectly affect engine load calculations and idle stability. It's crucial to analyze each circumstance carefully to determine the most plausible culprit behind the DTC activation and handle it accordingly. Also, keep in mind that the error might not stem from just one cause, but could involve multiple interrelated issues. When detecting DTC P0506, you may observe several symptoms manifesting during vehicle operation. One of the more common symptoms is rough idling, where the engine shakes or vibrates excessively while at rest. Another prominent symptom is stalling, especially at low speeds or when the vehicle comes to a stop. This indicates insufficient power generation from the engine. Additionally, you might experience a noticeable reduction in fuel efficiency, as the engine is not burning fuel optimally due to unresolved air intake issues. Recognizing these symptoms is essential, as they can not only provide insight into the underlying problem, but also impact overall vehicle safety and reliability. Addressing these symptoms early on can prevent more significant issues from emerging down the line. To initiate troubleshooting for DTC P0506, start by turning the ignition switch to the on/to position, marking the beginning of the diagnostic process. It's essential to record all freeze frame data and any onboard snapshots available, as this information provides crucial insight into the engine's performance at the time the problem was detected. Gathering this data can help pinpoint the root cause of the issue by revealing the operating conditions contributing to the DTC's activation. Additionally, reviewing the general troubleshooting information will ensure that all necessary guidelines are adhered to during the diagnostic process. Following these steps thoroughly helps set a firm foundation for effective troubleshooting, ensuring that no important data is overlooked. In this step, use the Honda Diagnostic System, HDS, to clear the diagnostic trouble code from the vehicle's memory after recording the necessary data. Clearing the code allows for a fresh start, enabling you to start the engine and assess its current status without influence from prior issues. It's crucial to have the HDS ready to gather all relevant data again after you've cleared the trouble code. Completing this step helps in determining whether the issue is truly pervasive or momentary, as a simple glitch may have triggered the DTC. Therefore, ensuring all protocols are followed correctly here will enhance the accuracy of subsequent diagnostics and repairs. Start the engine and hold its RPM at 3,000 without load, keeping the vehicle in neutral until the radiator fan activates. This step is significant because running the engine at this RPM allows the ECM to adapt to changes in engine temperature and monitor the cooling system's responsiveness. Maintaining this RPM, followed by letting it idle, provides the necessary conditions to analyze the vehicle's behavior accurately in a controlled state. Observing the radiator fan's operation is essential, since it confirms whether the engine reaches its operational temperature and whether the cooling system responds correctly, indicating that the engine management system is functioning as intended. This prepares the next diagnostic scan for comprehensive analysis. In this step, utilize the HDS to check the data list conditions, confirming the ECT, engine coolant temperature sensor 1, reading above 156 degrees Fahrenheit, the IAT, intake air temperature sensor, reading over 32 degrees Fahrenheit, and that the VSS, vehicle speed sensor, indicates 0 miles per hour. All these checks provide essential insight into the engine's operating conditions concerning the idle control system. Additionally, ensure the short-term fuel trim, ST fuel trim, is between 0.69 and 1.47, and the fuel system status, FSS, is closed, signifying the correct fuel mixture and no major malfunctions in the system. Proper readings here confirm that the necessary components are working within designated parameters, indicating that the engine management system is effectively monitoring and regulating operations. Next, monitor the OBD onboard diagnostics status for DTC P0506 using the DTC menu on the HDS. It's crucial to determine whether the screen indicates failed, passed, or executing, as this will dictate your next actions. If the screen shows failed, follow up with the specified next steps to delve deeper into the problem. In contrast, if it reads passed, that indicates that the system is currently functioning adequately, and additional diagnostics are required if there are other pending or confirmed DTCs. If the indication reads executing, continue to idle until a response appears. And if out of condition, the previous data checks need to be re-evaluated. Each of these potential statuses requires different approaches, emphasizing the importance of understanding the diagnostic tool's output. For this step, remove the intake air duct attached to the throttle body to gain access for inspection. But throttle body plays a pivotal role in managing air intake, and any obstruction or damage can significantly influence the engine's idle performance. During this inspection, look for signs of dirt, carbon deposits, or any physical damage within the throttle bore area. It's these elements that often lead to idling issues and can obstruct the airflow, thereby triggering the P0506 code. If dirt or carbon is present, cleaning the throttle body should be your immediate course of action. Should there be damages, further action will be required to either repair or replace the throttle body entirely. Careful attention in this step will be crucial in addressing potential problems contributing to the DTC. If you've identified dirt or carbon buildup within the throttle body during the previous inspection, the next step is to clean the throttle body thoroughly. A clean throttle body allows for optimal airflow into the engine, which is critical for maintaining proper idle conditions. Additionally, check the air cleaner element for any damage, as a damaged air cleaner can lead to excessive dirt entering the throttle body. This process addresses any preventable concerns that could give rise to the same issue in future operations. If substantial damage has been discovered, the necessary repairs or replacements should be undertaken before proceeding. Ensuring a clean and functional air pathway is essential for engine performance and reliability. If during the inspection you discover that the throttle body is damaged, it is imperative to replace it. A damaged throttle body can severely inhibit idle control and overall engine performance, and must be acted upon immediately. Once a new throttle body is installed, ensure that all connections and gaskets are securely returned to their correct placements to prevent any air leaks, which could lead to further complications. After replacing the throttle body, the troubleshooting process continues by resetting the ECM, electronic control module, to refresh the system. This reset allows the ECM to adapt to the changes made and to eliminate previous error codes from its memory, ensuring it operates based on the latest component status. In this step, use the HDS to reset the ECM, which is crucial after making any changes to the throttle body or other relevant components. Resetting the ECM enables it to recalibrate and recognize the new settings and parts. Following a reset, it's essential to perform the ECM idle learn procedure to ensure the new throttle body is functioning correctly and that the ECM can accurately manage engine idle speed moving forward. This procedure involves specific steps to allow the ECM to learn the new idle parameters based on the newly installed components. Properly executing these steps is vital for the system to operate smoothly and avoid recurring issues with idle RPM. After resetting the ECM, start the engine again and hold its RPM at 3000 without load, as previously done. The intention here is to maintain certain conditions under which the ECM can reevaluate its settings and learn about the engine's behavior with the new throttle body. Monitoring the engagement of the radiator fan is again key, as it signifies that the engine is reaching suitable operating conditions. This step verifies whether the idle learn procedure was successful and whether the ECM is adapting appropriately to the new component. It's essential to observe these conditions closely, as any deviations could indicate further issues requiring attention. In this step, recheck the relevant data list conditions using the HDS. Confirm that the engine coolant temperature (ECT) sensor is still above 156 degrees Fahrenheit. The intake air temperature (IAT) sensor remains above 32 degrees Fahrenheit, and that the vehicle speed sensor (VSS) indicates 0 miles per hour. Ensuring the short-term fuel trim stays between 0.69 and 1.47, and that the fuel system status (FSS) is still closed confirms the operational integrity of the system. These readings indicate that the ECM is accurately monitoring engine conditions and that the idle control system is performing as required. If these readings fall outside the expected parameters, further investigation may be required to obtain satisfactory results, highlighting the importance of precise diagnostics. After checking the data list conditions, verify whether there are any pending or confirmed DTCs present using the HDS. This is critical to ensure no other underlying issues are present that could be influencing the idle control system malfunction. If DTC P0506 is indicated, it signifies that the problem hasn't been resolved and directs you to further troubleshooting steps. Conversely, If no DTC appears, it suggests that the engine management system is currently stable and successfully managing idle RPM. This clarity ensures that should further issues exist, they are addressed immediately, while also confirming successful resolution of the previously indicated problem. In this final troubleshooting step, monitor the OBD status for DTC P0506 in the DTCs menu using the HDS. If the screen indicates passed, it means that all systems are functioning correctly, and the intermittent issue with the idle control has been addressed successfully. In this case, conclude the troubleshooting process and be aware of any other pending or confirmed DTCs that may require further action. Interest in maintaining ongoing vehicle performance is key. Therefore, if the status is anything other than passed, further diagnostic processes need to be considered. This step solidifies overall vehicle health and ensures the efficiency of engine management under all conditions. After completing troubleshooting, it's essential to perform a final repair verification to confirm that all repairs undertaken were successful and that no further issues persist. This involves conducting a test drive of the vehicle under various conditions to monitor engine behavior and ensure that all components are functioning as intended. During the test drive, pay close attention to the idle conditions, responsiveness, and if any warning lights appear on the dashboard. Ensure that the engine runs smoothly without stalling or exhibiting rough idling symptoms. This step is critical as it reaffirms the integrity of repairs performed, ensuring the vehicle is back to optimal operational standards. To minimize the risk of experiencing DTC P0506 or similar issues in the future, consider a structured preventive maintenance approach. Regular cleaning of the throttle body helps alleviate potential buildup of dirt and carbon that can affect engine performance. It is also advisable to check the air cleaner element frequently to avoid debris entering the throttle body, which could lead to operational malfunctions. Moreover, routinely inspecting crucial sensors such as the ECT and IAT will assist in ensuring that the engine operates effectively within the correct parameters. Implementing these preventive measures not only enhances vehicle longevity, but also reinforces reliable performance under varying driving conditions. In summary, addressing DTC P0506 requires thorough troubleshooting of the idle control system, with particular focus on the throttle body and its related components. By methodically following diagnostic procedures and ensuring that each step aligns with manufacturer recommendations, we can effectively point and resolve the issues leading to low idle RPM. Continuous monitoring of the throttle body along with related sensors is essential to prevent recurrence of the problem. Regular maintenance routines should be conducted to maintain the overall health of the vehicle's engine system. This proactive approach is crucial for ensuring that the vehicle operates reliably and efficiently, optimizing both performance and safety for the driver. Please like and subscribe to the channel. See you next time.